This video is concentrating on the topic job sequencing with deadline. This is a problem that can be solved by using the greedy approach. So first of all, we can see what is the meaning of the problem. We have given n jobs. Job means let us consider them as tasks. We need to done that jobs on a machine, and each job I has given a deadline value greater than or equal to 0 and a profit value greater than or equal to 0. Our aim is each job, when we consider each and every job, you will get a profit pi if you are completing that job before its deadline or completed by its deadline. Suppose that P1 is a job, let its deadline is equal to 2 and let its profit is equal to 100. It means that if you are completing that job, each jobs will be unit time jobs. That is, here we are considering the jobs as taking 1 unit of time, maybe 1 nanosecond or 1 millisecond, whatever may be. That is, that job is taking only 1 unit of time to run on a machine. So if you are selecting that job before its deadline, then you will get the profit associated with that particular job. And the machine, the machine on which we are working that jobs will be a single, it can only perform one job at a time. Okay, so we have n jobs are there. Each job has given a deadline, each job has given a profit. We have only one machine. The machine can handle only one process or one task at a time. Here we are considering all the jobs as a unit time jobs. That means it will take only 1 unit of time to complete. And you will get a profit pi if the ith job from the list is selected before or it is completed by its deadline. So the main task, the feasible solution here is that the set of all jobs which we have selected for, which can be, that is, suppose a set. If we have given 10 jobs in which we are only selecting 2 jobs which can be completed by its deadline, then we can say that that set is a feasible solution. So in such a manner we can find out different feasible solution, but there will be one solution which will give you the maximum profit. So let us consider this example. Here n is equal to 4. That means that we have given 4 jobs. And these are the names of the jobs P1, P2, P3 and P4. And let it be the profit given. Profit of each job is 100, 10, 15 and 27. These are the deadline of the 4 jobs 2, 1, 2, 1. So your first step will be you have to consider. So here if we are considering the feasible solution, if you are taking the job 1 and 2, it is a feasible solution because job 1 means its deadline is 2, job 2 means its deadline is 1. So if you are completing the job 2 first and job 1 second, we can complete those jobs before its deadline. So this combination of jobs 1 and 2, if they are processed in the order first 2 which is followed by the process 1, then you will get a feasible solution. And the profit you will get if you are completing the process 2 and 1 will be the profit of the second job, that is equal to 10, plus profit of the first job, that is equal to 100. So its total sum will be 110. In this manner, the second feasible solution that we can find is the combination of the process 1 and process 3. So what will be the order if you are considering the process 1 and process 3? That is, the first process means its deadline is 2. This is the first process, its deadline is 2. 3 means its deadline is also 2. So if we can arrange them in any order, since its deadline is 2, we can complete the task during the first session or during the second session. Here also, if you are considering P3, we can complete it by its first session or second session. So in this example, if you are considering the jobs P1 followed by P2 or P2 followed by P1, whatever may be the order, you will get a profit of rupees 115. How you will get the 115? That is the profit of the first job plus profit of the third job. 100 plus 15, that is equal to 115. So like this, these are the different possible combinations of jobs which can be selected which can be completed before each and every deadline. And we will get a profit value like this. And if you're comparing the different combinations, the total maximum profit you can obtain is 127, which is a combination of process 1 and process 4, which is processed in this sequence, that is first 4 followed by the first sequence. You will get a profit of 127. Okay, so this is the feasible solution. This is the set of feasible solution in which this one is the optimal solution. That is the set of jobs that we will select, which can be executed before its deadline or by its deadline, and whose total profit is 127 is our final solution. So the job sequencing problem is mainly used to find out the subset of jobs which can be executed by its deadline, which will give you the optimal solution or the maximum profit. So in order to consider this problem, the first step you have to do is that first you arrange, whenever you will get a problem for solving, you arrange the jobs according to the decreasing order of the profit. That is, you arrange them. So in the previous example, the order was process 1, process 2, process 3 and process 4, and these were the corresponding profits, these were the corresponding deadlines. So what you have to do is that you just want to make an arrangement. That is, at the first highest profit you will write first, then the next profit job, next profit job, and like that, and according to that you write its corresponding deadline. To if you are checking the previous question, that P1 has the profit 2, then we are selecting the next highest profit job, that is the last one, it has the profit 1, like that. 2 1 2 1 will be the combination of deadlines. And this is the smallest algorithm which will explain how this optimal solution can be obtained. So in this algorithm, we are just giving the algorithm name greedy job, and D is the set of deadlines of the corresponding job. So first, before executing the job, first you arrange all the jobs according to the decreasing order of their profit, and from this point we are explaining these parameters. D is the set of deadlines. So in our example, that set of deadlines means this array. This is the set of deadlines of the 4 jobs. J means here we are storing the result. That is, whenever you are selecting a job from the list for finding the optimal solution, that will be stored inside the capital letter J. N means the number of process we have to consider, or the number of jobs we have to consider. Here D means the 2121 list. J is initially empty, and N means here we have 4 jobs are there. So first we consider the first job from our list. So in our example, the first job we are considering is the P1. So this will be the first job we have to consider. This is the first job we are considering with profit 100. Its corresponding deadline will be 2. Then next is an I loop. I loop means next. So first job is already added in our solution. So our J, if you are considering J as an array, the J consists of first job we consider will be the P1. Okay, so this will be P1. Here we are considering the first job. Then the next jobs we have to consider, the first job is already considered, so the next we have to consider 3 jobs. So for I is equal to 2 to 3 or 2 to n, that is, we have to consider 3 jobs now: job 2, job 3 and job 4. Job 1 is already added, so we need not want to compute it again. Then you consider the second job from the list. The second job from the list is P4 with the cost with profit 27, and its corresponding deadline is 1. So you will consider the next job, that is P4, and you will check if you are combining, if you are including P4 to the existing one. So P1 is already there. If you are adding the P4 to this list, whether this will give you an optimal solution, or whether we can complete them, the combination of P1 and P4 in any order, whether you can complete. Is it possible for you to complete? If so, you will add to the existing one. So here you can see that the deadline of the P1 is equal to 2. That is, within the first within 2 point of time, 2 unit time, you can complete it. That is the deadline of the first process. And here that of the second process, the next process we are considering is P4. Its deadline is 1. That means you will get the profit of P4 if you are completing it during the first unit of time. And the second, if you are considering the second process, its deadline is 2. That means that you will get a profit for the second process if you are completing during the first unit of time or second unit of time. So in which order you can do it? Since here P1 has the deadline 1, first you complete that P4, and the second one has a deadline 2. So you can just extend that one to the second session. So in this case, if you are completing P4 first and if you are completing P1 second, then this will be a feasible solution, and its combination can be completed, no problem for that. There will be no kind of complications will be there, so you can add it to the existing one. And next you consider the third job from the list. So this is the style how this algorithm works. And this is the detailed explanation of this algorithm. Here we are writing certain steps in order to make the arrangements. That is, first we will provide 3 inputs to this algorithm, the set of deadlines. Here small letter j means the set of jobs we have to consider. So in our example, the 4 jobs we have to consider is this one: first job, second job, first job, fourth job, third job, and second job. So this array is giving as small letter j. So D is the set of deadlines, J is the set of jobs we have to consider, N is the number of jobs. So here this algorithm says that we have to arrange we have to consider N jobs for this problem, and let Di be the deadlines given, and N means number of jobs that will be greater than or equal to 1. You have to arrange the jobs according to the decreasing order of the profit, so that is specified here. Capital letter J, as we just specified, it is the output array, or it is the output that we are expecting where we are storing the selected jobs, and that is the optimal solution. And at the final stage of the algorithm, if you check, that is when you complete the algorithm, if you check J, we can see that all the jobs in J will be arranged according to the increasing order of the deadlines. So the output of this algorithm will be the set of jobs that will be stored inside J, and the deadlines of each job inside J will be in the increasing order of the deadline. So this will start with the initialization process. We are considering an imaginary job called 0th job, and its deadline is equal to 0. Then we will select the first job from the input array to J, and K indicates how many jobs are there in J, and here we have added first one job, that the first job is added to J, so K is equal to 1. So next we have to consider the next set of jobs, that is from second job to the last job. So first you will take the second job, and here using another variable that is called R, which is equal to the K value. Then we will check a while condition, and while condition says that what is the deadline of the rth job, what is the deadline of the selected job, that is the second job. You are comparing its value. This is the first condition of while. Second condition of while loop means that if the deadline of R job, if it is not is equal to the value of R. So these values will be compared, and whenever both the conditions are true, then R will be decremented. Then again we will check the while loop, and if this condition is true, again R value will be decremented. So we will come out of the loop whenever any of this condition is false. Then the next will be if condition will be verified, and in if condition also we are checking 2 conditions. So it is an AND operation. So this if loop the control will go to this step only if both the conditions are true. So here the first condition means that whether the deadline of the rth job. So now the value of R will be decremented. It will not be the same as that of the K value. So the value of rth job, the deadline of the rth job is compared with the deadline of the selected ith job. So here also the value of I is equal to 2 for the first iteration. And the second job will consider whether the deadline of the selected, that is the job we have to consider, is greater than R. If these 2 conditions are satisfied, then we will have a for loop, and in this for loop, this is a decremented for loop. The for loop is only up to this word do. So here initial value of K and the r plus 1 will be compared. So always this decremented loop will have either both the values same, k and this value will be same, or this value will be larger or this value will be smaller. In all other cases, the steps within the for loop will not be executed. So if this condition is satisfied, for each iteration of the q, j of q plus 1 will be is equal to j of q. That is, from the array j, the q plus 1, that is the the process from j will be shifted to one position right, and to the new to the existing position, the old one, the new one will be allocated. Each time the k will be incremented, that is, whenever a new value is inserted to j, the k value will be incremented. Then next we will consider the third job. The same process will be continued. Then we will consider the next job, that is in our example the last job. Then we will continue the steps. Finally, k will give you how many jobs are there in our answer. That is, in our optimal solution, how many jobs are there. That means j, actually j is an array which consists of our optimal solution. So how many jobs are there in capital letter J, that is given as output to the output of this algorithm. K means how many, it will count how many jobs are there, and J will give you which are the different process. So here the first point you have to consider, one important point you have to consider is that the I actually indicates the process we have to consider. 2 means you consider the second job in your list. 3 means you consider the third job in your list, like that. So this is the details of the smallest algorithm. That's all.